This video describes two ways to find the vertex or find the minimum or maximum value. All of those are the same thing. You may see any one of those instructions in a problem. The first way to find the vertex is to rewrite the function in vertex form, and it may already be in vertex form, in which case you're golden. If it's not in vertex form, you may need to use a technique called completing the square, which I explain in a later video. So if it's not in vertex form already, then you need to use completing the square to get it that way. Use complete the square if not in vertex form already. And if you're not sure what vertex form is, it looks like this. Vertex form. Y equals a times x minus h squared plus k. And you probably remember from an earlier video, the h and the k are your vertices coordinates. The h is the x coordinate and the k is the y coordinate. So there it is, vertex form. And if your function is in vertex form, then it's really easy to see what the vertex has to be. So in our first example, it is indeed in vertex form. And I'm going to be able to write down what the vertex is right away. That 3 is the A, right? And that tells us whether the parabola is right side up or upside down, opening up or opening down. And we don't care about the 3. What we're interested in is the subtracting 7 and the subtracting 1. So our vertex is located at 7. Remember, if it's inside parentheses, you're writing down the opposite sign, -1. Easy peasy. 7, -1 is where that graph is located. If you aren't given an equation in vertex form, and you don't want to use completing the square to figure out what the vertex is, get it into vertex form and then read off the vertex, you can also use the axis of symmetry and a two-step process to figure out what the vertex is. So the first thing I would do is to use the axis of symmetry, and I'll figure out what the x coordinate is. I'll need to plug x back into the function to find out what y is. If you're a little unsure of the axis of symmetry, then you may want to take a look at either the quadratic formula video or the using the axis of symmetry videos. So this first thing here is going to give us the axis of symmetry. So let's go ahead and find the axis of symmetry, and to do that I have to find my A, my B, and my C from my general form equation. A in this case is -2, B is 12, and C is -27. My axis of symmetry formula is x equals the opposite of b over 2a. Substituting in values for b and for a, gives me 12 divided by 2 times -2, or 12 divided by -4, or x equals 3. Sorry, x equals -3. So there's the x value. Now I'm going to need to find the y value, or the y coordinate, and I'll do that by substituting my x value back into the original function. So I have to plug it back into y equals -2x squared plus 12x minus 27. I'm substituting -3 back in for the x. -2 times -3 squared plus 12 times -3 minus 27 is going to give me my y. Negative 3 squared is 9. 9 times 2 is negative 18. 12 times negative 3 is negative 36. And I still have a negative 27. Ooh, I just made a mistake here. Looking at my work, I did not take care of that negative b. So it has to be the opposite of what b is. Negative b should be a negative 12, which means that, let's see here, my x is going to be a positive 3, not a negative 3. Which doesn't change my negative 18, but it is going to change my negative 36. All right, let's see here. Popping this into the calculator. Negative 18 plus 36 minus 27. And I end up with negative 9. So y equals negative 9. Remember what I'm doing here. I'm looking for the vertex. Well, now I found the vertex. The vertex's x-coordinate is positive 3. And the vertex's y-coordinate is negative 9.